upcoming speaker in line is the head of Customer Solutions Management at AWS India. He's an advocate for customers working closely with different AWS teams and partner networks. He's joining us shortly to advise on how enterprises can become resilient in leveraging chaos engineering practices in their digital transformation journey. Please join me in welcoming to our screens Mr. Biswajit Mohapatra.
Hello everyone. What a beautiful day it is. And I'm so excited to be here with you all today. I'm Biswajit Mohapatra, Head Customer Solutions Management at Amazon Web Services. Today, I'm going to talk about resilient digital future, chaos engineering in action. As you all know, the world has become more intelligent, more interconnected, and more instrumented. The pandemic has provided unprecedented challenges. In the same time, it had provided unique opportunities. Today, there is a change in business paradigm. There is reinvention of new business models, new way of doing things, as well as new way of building restless talent. Software systems are increasingly getting developed with enormous amount of complex architecture. Application, infrastructure, and storage complexities are growing exponentially, making systems more prone to failure. Today's modern distributed systems are associated with many unpredictable failure scenarios that are extremely difficult to monitor across failure points. So how do we really construct availability of these software systems? How do we manufacture performance of these distributed applications? How do we build resiliency as we prepare ourselves for any disruptive future? We all know chaos is inevitable. The question is how we can bring in engineering practices and principles and deliver those resilient distributed software systems as we move forward from here. There are three things we need to really take into account: accept, anticipate, and prepare. If I just talk about the pandemic parlance, what it's mean by accept? We have to accept that something like pandemic is going to happen. When it comes to anticipate, we have to anticipate that I may get COVID-19. And if I'm anticipating that, how do I prepare myself? Do I need to take a vaccination so that I am protected to a larger extent? The same principle, same analogy really applies to the software systems and the failure points that we really need to consider as we move along towards building resilient architecture. And chaos engineering is the answer for that. It's the discipline of experimenting on a distributed system in order to build confidence in the system's capability and making us prepared to withstand turbulent conditions in production. So what does that mean? Here, we have to break our systems for purpose, find their weaknesses, and fix them before they break when the breakage is least expected. That's why we need chaos engineering. It helps in improving the resilience. It will aid in uncovering all the hidden issues that we may predict that may happen within a software system. And how do you uncover those hidden issues? There are so many tools available in the market today where you can predict from known to known. From some known patterns, you can predict some known outcomes, or it could be related to known to unknown. From some known patterns, how do you predict some unknown outcomes? Or maybe the most leading edge capability that everybody is talking about when it comes to self-healing applications and dealing with those, how do I predict unknown from unknown and uncover all my hidden issues that's entrapped within the software system? It's very important to, again, expose the blind spots. And when it comes to exposing the blind spots, monitoring, observability, and alarm plays a very, very critical role. Chaos engineering as a practice leverages observability to discover and overcome system weaknesses. Without observability, there is no chaos engineering. I strongly believe in this. Organizations need to build culture of observing systems going forward from here. It's no longer about writing the code. It's all about adopting processes to build resilient systems, and many more that we are going to discuss now. To start with, how do we really engineer chaos? I call it as a 10-step process. The first step is all about understanding the system end-to-end. When it comes to understanding the systems end-to-end, break the solution into layers, components, and their topology. Understand your reliability requirements. Review previous data related to outages, failures, bugs, any RCAs you have done, or any postmortems that you have conducted. Identify weak points in the system and their potential impact. Understand if you have employed any existing monitoring capabilities within your environment. And it's also very important to review and maintain your backlog for experiments. Once you do that, you understand the system end-to-end, then the next step is to move to gaining organizational agreement. Obtaining stakeholder commitment before you start your chaos journey is extremely important. So you have to inform, you have to enable, and you have to socialize early. Reconfirming your strategic intents with stakeholders is extremely critical. You have to respect your SLAs, your SLIs, your SLOs, and your error budgets as well. Highlight track record of safety as well as success of your systems in your environment. And the most important part is you need to be prepared and anticipate objections. Once you gain the organizational agreement in this stage, then you move to the hypothesis stage, where you create hypotheses and plan experiments. Once we understand the system and we know that what we want to do and get the organizational agreement, it's very important to formulate your hypothesis and plan the experiments there. And at this stage, you have to enable the observability practices. When you talk about enabling observability practices, the most important part, you have to identify tools for observability. You have to consider various parameters of observability in terms of metrics, in terms of logs, in terms of traceability, capturing the baseline data before the experiment starts, and setting up alerts for exceptional values. Those are the activities you have to do on the enable observability stage. Once that's done, you move to the prepare for the experiment stage. You will have a checklist of what is to be prepared before you really start the experiment. So go through those checklists, identify and ensure that all checklist criteria are met. And once that is done, you are ready to run the chaos experiment. You can run it in terms of game day activities. You can plan for your pre-execution. You can plan for execution as well as post-execution. And continuously, you can experiment and run your chaos experiment iteratively. Once you complete this first iteration, you need to move to the analysis of the result stage and prove or disprove the hypothesis that you have formulated earlier. At this stage, you document the findings, evaluate your experiment results. If required, draw consensus, draw conclusions, and decide if test is sufficient or you need to formulate new tests. Once the analysis of the results are done, the next stage is communicate, communicate, and communicate. You have to communicate the findings and improve. So publish the chaos engineering experiments, which creates interest among the people who are going through it, who are observing it, address all the findings, and validate how your chaos engineering experiment is successful or unsuccessful in the context that we are doing the experiment. Then the next step is you grow your blast radius and repeat the experiment again and again. Once you succeed, you of course have to grow your blast radius. As you know, one success leads to another success, leads to larger success. So this will help iteratively getting the organizational agreement better, and the entire chaos engineering practice and implementation will be expanded within your organization. Once that is done, then you move to expanding it to production. It doesn't necessarily mean the production environment. It can be expanded to the next level or to other sensitive applications within your organization as well. So the key point is start with game days in production, inject chaos engineering into continuous delivery pipeline, try to have a autopilot mode wherever there is a new deployment, try to have part of your testing at least, which is automated as part of your chaos engineering routine. Assess all the processes that's in place at this point of time. The whole process, as you must have already anticipated, is extremely cyclic in nature within the organization and need to constantly expand into other part of the organization as you move along in this journey. Having said that, these are the 10 steps, but in reality, chaos engineering implementation is extremely difficult. Predominantly because of the reasons like you need to stitch together different tools as well as homemade scripts. It's not easy. Agents or libraries are required to get started. At times, it's extremely difficult to ensure safety. As well as it's difficult to reproduce real-world events and multiple failures at once. And there comes the solution that AWS comes up with, right? Fully managed chaos engineering on AWS cloud. What does that mean? If you look at the steps, you have a brainstorming step to start with. From the brainstorming, you move to hypothesis, you create experiments, you start experiments, and after some point of time, you stop the experiment, you analyze the results, and you incrementally optimize based on the lessons learned. Fully managed chaos engineering services on AWS cloud is easy to get started. It can help you to simulate real world conditions, and in the same time, it will safeguard against some of the disruptions that you are preparing yourself to address. So how does this really work? When I talk about brainstorming, what exactly you are doing during brainstorming, right? You need to work through your product owners to prioritize your time for reliability. Of course, in an agile model, you have to invite your team, those who build features, test them or consume them through the services. You have to get their viewpoints there. And finally, identify what behavior exactly you are planning to simulate as part of your chaos engineering experiment. In the hypothesized states, based on the collaboration with multiple teams that you've done during the brainstorming, you create your hypothesis, determine how the system will degrade, which components will impact, how this will reduce your customer experience, how it will be measured, and what your team will do to restore the services. And this hypothesis, answer to these questions will form the basis for your chaos plan. Then the next step is to really create experiments where you engineer the state of the system, not the methodical approach, yet some major organizations, of course, use random chaos mechanisms as well, even in production, right? At this point of time, you need to better understand the practice as well as your system. You have to create your attack plan by degrading the dependencies outlined in your hypothesis. From AWS context, AWS suggests experiments are created using AWS Fault Injection Simulators, what we call as FIS. Once your experiments are created, then you need to start the experiment. In this phase, your fault actions are injected to AWS resources and matrices are monitored, maybe using CloudWatch or Event Bridge, right? So once the experiment continues for some times, you stop the experiment. Sometimes, as per your plan, experiments can stop automatically once all the actions are complete. Or maybe an alarm or trigger is also can be created at this point of time. So once the experiment is stopped, you got all the analysis results. You analyze those results that you have got and identify the points that are weakness points or weak points for your resilience journey, right? So you review the results. Some of these results are outcome of the actions that you chose while creating experiment templates. For example, your CPU spikes, your increased latency, your HTTP error code or network packet issues. So those are the results that you can analyze and review at this stage. And once you get a deep understanding of systems behavior, you can move ahead, capture your lessons learned, how systems reacts, identify the root cause of the failures and improvements, and again, kind of in a cyclic manner, fed back that to the brainstorming phase for proper planning. So that's what you do as part of your fully managed AWS chaos engineering services. How it really works, of course, FIS is well known in the industry today for optimizing performance and reliability. You can start with features like AWS native and pre-built integration that you can focus on as part of your AWS FIS journey. You can discover applications weaknesses at scale in order to improve performance, observability, as well as resiliency. Build the experiment templates, scripts that can simulate blind spots to manage unexpected outages in production. FIS also can help you in leveraging cloud automation and AWS CloudFormation DevOps pipelines. It also provides built-in safety mechanisms and guardrails in the form of stop conditions, which stop an experiment before it runs, where to stop an experiment before it really runs out of control. So those are the things you can plan as part of your overall AWS FIS implementation journey. So the next question is, how can we automate chaos engineering with AWS FIS capability, right? As you see on the chart, the architecture diagram depicts how AWS FIS can bring application resiliency, how the entire process can be automated using AWS CI/CD pipeline. The workflow onboard FIS in the early stage of application lifecycle management by introducing fault injection during the testing process itself, right? So what's happening here? Developer is committing the application code into the pipeline. Then the Lambda services will initiate AWS FIS and SSM in the pipeline. You define the baseline, perform hypothesis using experiments on targets. In the architecture here, as you see, we have used API gateway, RDS, and serverless application as targets for injecting faults related to API errors, RDS DB instance, as well as HTTP error code respectively, right here. So we'll collect the results when the experiments are done as shown in the diagram as per the experiments and the hypothesis defined. We'll further analyze the results from above experiments to baseline metrics as well as threshold. Define meaningful business SLAs and set notifications to bring more resiliency into the system. Further experiments and hypotheses are created out on other aspects of application using more actions on different targets to bring the continuous improvement in the journey. This will help creating robust infrastructure and provide optimum user experience that's very, very critical in today's business context. As you all know, today's businesses are rebuilding are under experience. So if you are not really providing resilient systems or not rebuilding businesses around experience, we are not going to be very successful from here, right? What are the typical supported fault injection techniques that FIS support? This is probably a list of those techniques. You can inject server errors, you can stop, reboot, and terminate instances. You will be in a position to perform API throttling, increase memory or CPU loads. You can kill processes related to your EC2 instance. You can perform latency injection as part of your EC2 instance. In ECS, you can do container instance termination, increase memory or CPU spikes that you can monitor. You can terminate nodes as part of your Kubernetes services. You can do database stop, reboot, and failover as well as part of your IDS services. And many more that's in the pipeline that needs to be coming in coming days. So what's the overall value proposition that we are talking that AWS FIS can bring into the table? If you are looking at improving your application performance, your application resiliency and observability, you are interested in getting superior insights by generating real-world failure conditions, you are looking for a fast and easy way to get started with your fault injection experiments, you are in the process of validating how your application performs on AWS, or you want to safeguard your applications while doing those chaos tests using fault injection experiments, then AWS FIS and the automation around it is the answer. So what we have seen as part of one of the research that done by Data Foundry in 2021, AWS FIS chaos experiments brings in 30% reduction in revenue losses by preventing lengthy outages. Almost 25% reduction in cloud spend savings with optimum performance and capacity planning. And almost 100% reduction in third-party tooling license cost. So that's basically the clear differentiator, clear value proposition that AWS FIS brings into the table when you are running chaos engineering experiments. We need to remember some of the rules of the thumb. Based on my experience, chaos engineering experiments brings a lot of value when you are starting really very small, making your chaos plan very iterative, very incremental in nature. In the same time, if you are doing chaos engineering experiments, try to remain as close as possible to the production. Do the simulation in an extremely production-like environment. Work towards minimizing your blast radius so that you pinpoint on the problem and focus on where exactly you are trying to build those resilient points to avoid those failure points that you may overcome. Have a mechanism where you are in a position to perform emergency stop in the case of any unpredicted behavior or disruptive behavior that may jeopardize your overall systems and put your business in risk. So ever do not ignore to put that emergency stop practice in place. Also, while running the chaos experiments, you need to be extremely careful with the state that cannot be rolled back. So, in reality, in life, we do a lot of reversible as well as irreversible decisions, right? If it's a reversible decision, probably you are better off. But if you are doing a chaos experiment where the decision is extremely irreversible, you need to be careful with the state. And you know that this could bring in serious repercussions because you are not in a position to roll back. So remember these rules of thumbs. In the same time, when I was talking about changing new business models, new business paradigm, and while everything moving to cloud, every customer adopting next-gen technologies, it's extremely becoming important for organizations and the systems to become resilient to the challenges. The systems needs to be resonant to the environment, and in the same time has to be very rugged in adversity. I'm not sure how many of you really recognize the image that you see on this chart. It's a small microscopic creature and it's called tardigrade. And tardigrade is known for its resiliency. It can survive extreme temperature conditions and extreme frigid conditions. It can stay without food, without water for a long period of time. Probably it has adapted it in such a way that it can overcome any disruptive actions that it may get exposed, bearing probably death of the sun, right? So today's business really need to demonstrate those tardigrade resiliency. And I strongly believe chaos engineering with all the observability practices in place to manage, monitor, trace, and log is the way to survive future disruptions. Chaos doesn't really cause problems. It actually reveals them. So with that mindset, I will request all of you to continuously approach systems from a human perspective with a mindset of resiliency, and chaos engineering is the way to go when you are trying to build resilient systems. With that, I'll conclude and I'll be very happy to take any questions if there is. Thank you very much and thanks for the opportunity.